Hello everyone, this is the first lesson recording for IM2, October 12th, 2020. Some announcements. There will be quiz number 4 actually, next class. It's going to be on dilation and polygon similarity. To prepare for dilation, you should be looking at your notes on dilation plus the Desmos exercise on the Unit 3, Day 5. That's 2 lessons ago. And also polygon similarity, you should be looking at your notes, class notes, as well as the Desmos activity, Unit 3, Day 6. That's the previous lesson, as well as the homework number 14. Now, to access your past Desmos activities, just go to student.desmos.com and log in using your Google account, and it should give you history of your past activities, I believe. So let's talk about dilation versus similarity. So dilation and similarity are two related but different concepts. So I would like you to answer in private chat, what do you think are the same between dilation and similarity? And then second, what do you think are different about dilation and similarity? And finally, how are they related? Great. Well, dilation and similarity. How are they similar? Well, dilation is a transformation that produces figures similar to original by proportionally shrinking or stretching the original figure. This was notes from the previous days. So in math, when we say something is similar, they look alike, but they may be different sizes. So two polygons are similar if there is a sequence of rigid transformation and dilation that carries one onto the other. So how are they different? Dilation is a transformation, and similarity, we're referring to something being similar as a result of dilation. Okay, but then the working definition, how are they the same? Well, as a result of dilation or similar figures, the corresponding angles are going to have equal measures, and that all corresponding sides are going to be proportional. So that is how they are going to be the same. So goal for today, we're going to be exploring shortcuts to prove similarity triangles. Remember that in similarity, all corresponding angles have to be equal and all corresponding sides are proportional. For triangles, this means we need to check all 3 pairs of corresponding angles and calculate 3 pairs of size ratio to compare. Now, I don't know about you, but if there is a more efficient way, I would like to try that. And mathematicians are renowned for being lazy, or we like to say we are more efficient, but whichever way you look at it. Okay, so for triangles, how can I get by with checking less? Do I always have to check all 3 pairs of corresponding angles and calculate 3 pairs of side ratio to compare, or can I get away with less? So that's what we're going to be looking at. So you're going to explore, what if we have just 1 corresponding angles that are the same, or 2 corresponding angles that are the same? Is that enough to say that those figures are congruent? What if we have 2 pairs of sides that are proportional, or side and an included angle and another side that are proportional with a congruent angle in between? So you're exploring all of these. And to do that, you're going to be using this tool to create conditions and experiment, and I am going to show you that in a minute. And you're going to record your evidence, your findings in this evidence document, and you're going to be turning this in individually. So everybody is going to make a copy of this. And if you find that if you just have 1 corresponding angle that are congruent is sufficient to prove similarity always, then you're going to paste this happy face. Or if it's not, then if it's not necessarily similar, then you're going to take a screenshot and paste a counterexample of it. Okay, so let me explain that more in detail. So you're going to be working in teams, and the resource manager are the person number 3 in alphabetical by first name. And by the way, your teams have been formed with your requested team members. So make sure everyone can use the tool. So that's your resource manager's duty. Everyone explores A together. I am going to explore the A, just one corresponding angle to give you an example. And then the task manager is the person 4 asks if everyone is ready to discuss result for 2 angle AA similarity, and if everyone shares answer for AA similarity, and discuss if there is any disagreement. And everybody then moves to the next condition and repeat from number 2. Okay. So this is the document that you should all be making a copy of so that you can modify, and you follow the directions. Here it says introduction. We've learned so far that to verify 2 polygons are similar, we need to check all corresponding angles are the same measure and all corresponding sides have the same ratio. Okay, so that means 6 different comparisons, comparing 3 pairs of angles and comparing 3 sides ratio. Too much work. So in this activity, you will discover what conditions are sufficient to guarantee triangle similarity. And you will use this e-tool, this tinyurl.com link. And that looks like this when you click on it. And I'll show you how you do that. But let's go back to this document. So for each of the conditions below, you will set up the condition using the e-tool, then manipulate the triangle to see if the triangles must always be similar. So what do you think? Before you start the activity, make an educated guess. Which of the following will be sufficient condition? Edit yes or no for the condition below you think is sufficient to guarantee triangle similarity. Again, this is just thinking out loud, okay? Before we explore, do you think if you just have one pair of corresponding angles that are congruent, do you think you would always create a similar triangle? Or if you had 2 corresponding angles, 2 pairs of corresponding angles that are congruent, then do you think you would always create similar triangles? Or similarly, if you have 2 pairs of corresponding sides that have the same ratio or proportional, then do you think you would always be creating a similar triangle, and so on? Okay, so this SAS is the angle is the included angle that are congruent. SSS is all 3 pairs have the same ratio, and SSA, that's the 2 pair of corresponding sides have the same ratio and the excluded angles are congruent. Remember, this was the one that was excluded in congruence because there was 2 different situations that you could create that were not congruent. Okay, so and that's also the donkey theorem that we say that it's a bad word we don't say. Okay, all right, so now let's look at the condition A, similarity. Having 1 pair of corresponding angles to be congruent, sufficient for triangle similarity? If yes, paste a happy face. If not, paste a counterexample. So I am going to demonstrate this, and then from then on afterwards, you're going to go into your groups and you're going to be working on AA similarity or side-side similarity, side angle side similarity, side similarity, and then you are going to be considering this, and then you are going to keep working on it until you get to the end. And again, you are going to be turning this in as part of your classwork. So let's go to the tool. We are looking for what if you have a pair of angles that are the same. Okay, so I shouldn't have locked. Let me undo things. Okay, so let's assume that you have triangles that look like this in your. Okay, so, and you can manipulate this. So now we just want one of the pair of angles to be the same. Okay, let's just say, okay, I want angle D to have the same measure as angle C. Okay, so if I want to do that, I click on that angle here. You are going to see this lock symbol. You click on it, and that's going to give me a option to lock it with another angle. Okay, now these two angles are always going to be the same. When this one changes, this one's also going to change. This way we know that the angle is always going to be the same. Okay, so can I change this anywhere and create two triangles that look very different? Because remember, if you can just create one triangle that looks very different, then it fails a similarity test, right? Okay, what about this? Okay, so here the two triangles have the same angle, okay, same corresponding angle, but obviously we don't really care about the side ratios or other angles. Okay, when you have these two triangles, do they look similar to you? Not at all, right? So I can take a snapshot of this, screenshot of this, and I can paste this and into my document here. Okay, that's huge, so I'm going to make it much smaller. Here we go. Okay, and I'm going to get rid of some of the spaces that I don't need. Okay, so this just shows that this is the triangles are not similar. The triangles are not similar. I can just say that as a conclusion. Okay, and now you are going to go into your groups, and you are going to be exploring AA similarity and the other similarity. Let me show you a few other features of this tool. Okay, so again, I told you this. So if I wanted two of the angles to be the same, then I can say click on another angle here. Okay, and I click on the lock here and say I want to lock it with this. That means these two pairs of angles are the same, and this pair is going to be the same. Okay, now you can change, move this anywhere. Okay, you can certainly move this as well, move the other, but the angles are going to be the same. Okay, so can you create two triangles that are not similar? Okay, how will I check to see if they are similar or not? You can also always use transformation. Okay, so if you go to transformation, so if I click on the figure, okay, if I click on the figure, it gives you reflection option. I can reflect this along, okay, and that dotted line is a line of reflection. Okay, I can reflect, or I can rotate by putting a center of rotation, or I can also dilate. Okay, that's the dilation. And if I just want to translate, I can move things like this. Okay, so for example, if I think these two are similar, what I can do is I can move this to see that those two vertices are the same angles, and then I can use rotation with the center of rotation right there and move this like so. Okay, except the corresponding angles do not are not matched up, so I need to reflect. Okay, and now I know. Okay, anyway, that's what you're doing for, and the lesson recording will continue after you are done with this activity.